Please go. Please go.
Yeah. Okay.
Shall I share the screen or I have to?
No. Initially, we'll start and then you can go live.
Sir, we are live now.
A very good morning to one and all. I, Ms. Nivya Chogule, feel very privileged to welcome you all on behalf of KIT's College of Engineering, Kolhapur, Maharashtra, to the CSI Regional Student Convention 2020, Region 6, which is organized by Computer Society of India. As Brian Herbert said that the only way to discover the limits of the possible is to go beyond them into the impossible. I'm glad that you all decided to invest our time amidst this global pandemic in something useful, and I hope we all learn a lot today. So may I request Professor Dr. Kalish Ma'am, Head of the Department CSE, enlighten us with her encouraging words and give us all a brief introduction.
Thank you, Divya. Very good morning to all the dignitaries. Dr. Rupesh Devan, Associate Professor, IIT Indore, Mr. Ajit Patil, Students Branch Counselor, CSI, Mrs. Archana Sawant Ma'am, Associate Professor, as well as Faculty Coordinator of this particular event, and students, friends, as well as faculty members who have joined this session. Warm welcome to you all for this exciting session of invited talk. So today, the CSI Convention 2020, on second day, we have organized invited talk from eminent personalities from industry as well as from academia. So today we have with us for this session, Dr. Rupesh Devan from IIT Indore. So actually he's a native of Kolhapur. So he was graduated from Shivaji University, Kolhapur, as well as he has completed his post-graduation in Shivaji University, Kolhapur. So welcome, sir, for this session. So actually, the CSI convention is scheduled with the objective of promoting and facilitating the development of technical skills and talent of students. And CSI, Computer Society of India, has very rich tradition of sharing advancements and practice of computer engineering and technology, science and engineering, also sharing the latest in the field of society to industry people, researcher, and bringing them on a common platform, a very iconic and a special thing. So today, Dr. Rupesh Devan is going to deliver his invited talk on expected post-COVID-19 development in nanotechnology. Welcome, sir. So we are very eager to hear from you. I request Dr. Rupesh Devan to proceed with his invited talk. Thank you.
Okay. Let me share my screen first. Will you allow me to share screen, please? Yeah, thank you. Yeah, thank you, Dr. Kalish ma'am. It's like a homely treatment for me because I'm from Kolhapur and getting certain call from Kolhapur and to deliver talk on the topic, which is a little bit different, not in CSE, computer science, but I'm trying to give you a glimpse things that how this COVID nanotechnology will be useful for the computer science technology. Thank you for a nice introduction. And as you have seen this since last 1 year, we are hearing the word COVID, and this is called as COVID-19. Few people call it as a China virus. Few people call it as a Wuhan virus nowadays. And we have earlier version 1. Now we have version 2, which is coming from the Great Britain. And then we are afraid of getting again this pandemic throughout the world. So there are many things going on. Few are positive, few are negative, but most of the time it's negative. It's better because nowadays the word positive itself is giving a negativity. Because if someone asks you, are you a positive, then you cannot say clearly that you are positive. In fact, your mind is positive. You are having positive energy, but because of COVID, everyone wants to say that I am negative, right? So things have been changed. Earlier, we used to be in a classroom with our friends, and then teacher used to teach us many things. Even teacher used to enjoy the students' interaction in the class. But nowadays, everything is going on live. Few days we were at home watching TV, wasting our time on WhatsApp and Facebook. But you have to think in other way around. Because of that, we have Zoom meeting platform, Google meeting platform. So many development happen. So this is like a mixed environment for the society, for the world, that COVID had taught us many things. And in fact, it has taught us how to live without lavish life, how we can stay with minimum requirement, how we can go live, go with our life without much more requirement, or you can say the minimum requirement. And in this development, I believe that nanotechnology is one which is going to give you a major wealth in near future. So as you most of are from CSI background, so you might have not heard about this nanotechnology. I will give you a little bit hint or a little bit idea about the nanotechnology. What does it mean? How it's come in picture? How scientists explore this? Is it new or is it old? And then what kind of technologies people are using? And then we will move to actually a COVID, what COVID has done to us, how this has affected on our development, and is it going to affect on nanotechnological development, that we will see in today's lecture. So when you're talking about nanotechnology, you should know the scale. It starts with the bigger one and then moves to smaller. So for the better understanding, I'm starting with a watermelon, which is approximately size close to 32 10 centimeter in diameter, and then smaller than that is a coin. So most of you have seen 10 paisa coin, which was earlier in a metal form, which was hardly of 1 centimeter, and now we can see this 5 rupees or 10 rupees coin, which is approximately 1 inch or around 2 centimeter. But rather than that, we have to look for the ball pen, which is having a very small tip. And you might have heard about the dimensions. Like if you go to buy a lead pen in a shop or in a supermarket, then you can find there is written on this lead pen box that 0.5, 0.7, 0.4. What is that? That is actually a dimensions of that lead. That is a width of that lead. So ball pen is to be in that way. So this ball is to be much smaller, and it is to be in around 1 millimeter to 0.5 millimeter diameter. The next smaller thing is hair, which everyone is having. So this size is to go around 100 micron, plus minus little bit. Then we can see this with the naked eye, but more smaller part, we have to go with optical microscope, which is a Raybird slate, which is approximately 5 micrometer scale. And what we are hearing right now is a coronavirus, which is again in that scale, not much bigger, but it is in micron, 1 to 4 micron size. And it has let the world change completely. But is this the nano? Of course, this is not nano. The scale is far beyond that. So if you want to go a little bit smaller, then you have to think about the gold nanoparticle. Gold is a golden in color, but if you change the dimensions into nano, then it can be a red, or even you can go with different colors. So that gold nanoparticle used to be in 10 nanometer. So here we are moving from a meter to nanometer. That means we are talking here, if watermelon is 10 raised to minus 1 meter, then we are here talking about 10 raised to minus 9 meter. Right? So this is what the scale for the nanometer. So gold nanometer, gold is the best example. Gold nanoparticle is the best example. But what excited more to the scientists is a carbon nanotubes for these nanostructures. And then we are talking about benzene, or you can say the graphene, and even we're talking about the water molecules, how to get energy from this. So this is what nano is, and this nano we are going to see. But is this nano invention of the scientist? Of course, no. This is actually inventions of the nature, but it takes a long time to understand the scientific community or industrial community, how this nano works actually. And the best example is a lizard, which is available in each and every home at either corner or at the wall or the roof. So you can see this lizard is walking easily across the roof, and it's very rarely fall down. So what happened here is this lizard has a dendrix at its leg, and that can hold the particles which are on the wall. Even though wall looks like to be plain, very plain, but if you go at the micro scale or nano scale, then it has having a very rough surface, and that rough surface is used to suck over there. So the dendrix can hold those rough surface. So this technology is converted into a nano format. So how we can convert these dendrix in our real life, how we can synthesize these dendrix, and then we can use this for real life application. The next best example is a spider silk. If you have old homes or if you not clean it, then you can easily find it at the corner, definitely. You can see this insect is very small, but it used to get a very big net. And this net is prepared by saliva. What is it? It is not a thread, but it is a polymer. And this polymer is having a very good stain. It can catch its own foods, or you can see it can catch the insects very easily, which cannot escape. So you can just imagine such small, tiny particles which are connected together, and to build up this big net and having this small, strong strain. Then scientists start thinking about how to convert such kind of material and how to get the nanostructured material. The next one is a self-cleaning butterflies. So you are watching butterflies since long time, right? Since your childhood, but you never see the butterflies get dirty. It's always looks beautiful, lot of beautiful colors, and very much clean. So we have to think how this is happening. So these butterfly wings are having dendrix, which are in very small size, it's a nano size, and whatever water droplets or dirt particle come over here, they get clean easily. Just imagine if this structure been known to us earlier, and that is having this de-infection properties, then we would have used it with our clothes, so we would have not afraid of the COVID. So that means we have to think about how these butterflies can give us the knowledge, and we can get rid of this COVID pandemic. The next one is optical nanoscience. This is the creature which I love playing with. Why? Because you can see it started with the black color, and you can name the color from the 7 color systems. You can have it. Even a lot of mixing is there. Why this is happening? What biological properties this insect is carrying? But if you burn this particular insect, then you can have a carbon in short. So you cannot know what exactly is there. So you have to study its life property. So just imagine if you can create your own material synthetically, then definitely you can have such kind of photons. And the next one is water collecting beetle bags. So these are available in a desert, for example, the Rajasthan. It's very difficult to get water over there, but you can find these insects surviving for longer time, and it's collect water on its own. So this structure is very good. What happens here is water droplet which are available in the environment, this will be condensed over here, and as soon as water droplet size increases, this water droplet move along the surface, standing surface, and reach to its body. So it can collect its water on its own. So you might have heard that real life Punsu Wangru. Why I say Punsu Wangru? Because everyone of you have seen the 3 Idiots movie. So you have seen this real life Punsu Wangru. He created an ice tower in open environment, and during the summer, the same technology he would have used. So scientists are trying to understand the nature in a nano world. The next example is KITCoEK. You know, this bird is having a big size, almost close to its body, but even that it can fly very easily. Why? Because these KITCoEK is very porous, very lightweight. So scientists try to understand what exact the material is, and they try to mimic it so that aeroplanes can be much lighter, and then you can save the energy. So this list goes on increasing, right? So that means whatever is there, we are trying to learn from the nature. But do you think that our ancestor was not knowing about this nanotechnology? Of course not. They were well known about this nanotechnology, but the only thing is that they were not coining this word. They not use this word nanotechnology. What they did, they used the stained glasses. Yes, they use the gold nanoparticles, silver nanoparticles of different sizes, and then they beautifully color this all the glasses. You can see here these glasses having red, green, blue, white, and different colors. So they use only gold and silver nanoparticles. But unfortunately, what happened? They not put this in a written record. That means, or they might have written somewhere, but we are unable to trace it out, and that's make us to study again how to convert this gold into a nanoparticle format and find out the different colors. And we have wasted a lot of time. So our ancestors, let's imagine before 600 or 700 years ago, they were knowing this nanotechnology. Just imagine if we were having the written record, and then we would have explored further properties. Then today, whatever we are seeing that how to kill this COVID-19 virus, we would have been using these nanomaterials very easily, but it not happen. So you can see this nanotechnology, this gold nanoparticles, silver nanoparticles of different sizes have given different colors. So we are trying to mimic these technologies again and again from the nature. But when this nano word is being invented, this idea of the nano was given by Professor Richard Feynman in his lecture at American Chemical Society meeting in 1959. And what he said, there is plenty of room at the bottom. That means he told the scientists that if you go more and more deeper, or if you reduce the size more and more, then you can explore better properties. But again, he put with the one question that is there no way to make electron microscopy more powerful? Why? Because if you want to go to the nanoscale, that means you are moving from virus size micron, and then you are moving to nano. That means you should have to have a microscope which can see these nanoparticles. And at that time, only we were having optical microscope, which is having the limitations. So to reach much smaller size, what he believed, or what he told, that you have to have electron in your hand to control it. Then you can control its wavelength, and then you can see the structure. So these statements make the scientists more excited. At the same time, the group from Professor Charles Oatley was working on this particular electron microscopy, and they introduced the first commercial SEM stereoscope built up by Cambridge Scientific Instrumentation. And then you can see the different structures. You can see here these hexagonal or one-dimensional structures which are grown in the form of trees can be observed. So this really let us understand the nanotechnology. But is it really being used in day-to-day activities? Of course, yes. Where you are watching right now, this lecture, either on cell phone or laptop or somewhere else, this is really having a use of nanotechnology. So you can see here the TV, which was bigger in size, now has been moved to flat screen, so which is again smaller. Now we are talking about the foldable screen. So just can imagine this much bigger size instrument has been converted into a smaller size. Why? Because the component which were fixed inside the TV has been replaced with the nano size components. That means size of the component inside this particular box has been replaced completely. Right? That means really we are using nano in day-to-day activities. The best, another example is a computer. The first initial computer where this man is sitting inside was occupying 20 by 20 square feet area. And now you can see you have laptop, even you can have a pad in your pocket. Why it happened? Because the ICs which were being used, or transistor which were being used for the computer, has been reduced in size. Earlier it was much bigger, and now we can see large number of components are fixed in a smaller size. And this is happening according to Moore's law. He was an IT person. What he said, every year the transistor size on one particular centimeter square area will be double. And that's what's happening. So other transistor size was approximately 1 centimeter, and now we are talking about 1 to 5 nanometer size. So till 2017, it was twice, but after that it's become 2.5. And then scientists thought, okay, it's very difficult to control. So they have decided to make it with only 2 twice. So you have to look at the revolutionary force. So you have seen, or you have read that we have textile industry, then we have rail industry, which have a very good wealth creation. Then automobile and computer is ruling the world. Of course, automobile has reached to the saturation state, but this computer technology is still being widely adopted. Everywhere we are trying to make the automation. In fact, this automobile is being connected with the computer, so you can have a driverless car on the road. So Google is working on it. So there is a very good fusion of this automobile and computer. What next is a nanotechnology. We are at the introductory phase. We have not yet used it completely, or we have not yet widely adopted it. What we are expecting is in the next 10 to 5 years, we will start widely adopting this technology, and it will continue till the end of this century. And after that, it may reach to the super saturation state, or you can say it will reach the end of the rapid growth. That means we have to consider connecting computer and nanotechnology together, how it will be. Artificial intelligence can be a best example of this, right? So we will see how this artificial intelligence will be useful, how you guys or you computer science engineers can club with the nanotechnologists and take the lead in development of the world or development of the society. So there are different uses of this nanotechnology. It started with energy storage. Nowadays, energy prices are much higher because we are afraid of getting down this petrol, because petrol price is increasing, diesel price is increasing. And at the same time, the stock of the petrol or diesel across the globe is going to reduce. So we have to think about how to convert the energy, solar energy, into electrical energy. So conversion is one of the best options to get an energy. But is conversion help us? Of course not, because nighttime, how to use that energy? Because we don't have a sunlight in the nighttime. So we have to store the converts energy, and that's why we need energy storage. So these two, energy storage, production, and conversion, are most important part. This nanotechnology is being used in our agriculture product, also water treatment. Agriculture product to enhance the productivity of the crops, and the water treatment is most important because in the although in India, Maharashtra, specifically in Kolhapur, we have very good water, but you have to look for the regions in West Bengal, Malwa region, in Punjab and Rajasthan. Getting drinkable water is very difficult. They are having high hard water, which is having TDS close to 500. So we have to consider use of nanotechnology for the water treatment, at least for the good drinkable water. COVID has let us understand how we can use this nanotechnology for the disease diagnosis. So this is one of the most important thing, right? Also, we have to think about the drug delivery. Since last 1 year, we are expecting that drug will be delivered and we will get rid of this COVID. So till today, we don't have much success. So scientists are thinking if we can use the nanotechnology or nanomaterials for the drug delivery. For food processing and storage, there is another one. Air pollution. The best example is Delhi, where you can find a lot of fog, a lot of smoke these days. Why it is coming? Because the farmers from Punjab are burning the crops, and then it converted into a smoke. So air pollution is a huge issue where we have to consider use of nanotechnology for this remediation. Construction again is there, health monitoring and pest control. So these are the 10 most important things where nanotechnology is being used. But today we are going to talk about the COVID, how we can consider this nanotechnology in a COVID. Of course, not in a COVID vaccine. I'm not expert in that. But everyone is talking about in getting rid of the COVID. So scientists, biologists might be doing their job to kill this COVID virus, but we will see there are different aspects, right? During this COVID pandemic, you have seen that manufacturing market has going down. What expected was here. So everyone was thinking to create massive wealth from this manufacturing, and everyone was expecting that by 2025, it will get double. But COVID pandemic, which started in last December, has led is reduced, and what we are expecting, it will remain constant for the next 5 years. But what we are expecting, that nanotechnology, if we use, then we may support to increase this market. And then it comes to you guys, which is the software market. Of course, every year in India, at least, the software market was increasing drastically. So if you look at the trend of this graph, which was linear, in fact, if you start increasing this, then it will have crossed almost 2,000 or 2,500 billion in next 2 years. But what happened here is it is getting down. We don't know what will happen next, but what we are expecting, it will remain constant. But you have to look towards the artificial intelligence. If you are going to connect this nanotechnology and computer together, then definitely you can have a better software market. So let's talk about the COVID, right? So when COVID started, before that, we were talking about the pollution. And we were looking for the better earth with a much better environment. And after COVID, what will happen? We don't know. Are we going to get what clear environment we have right now because of COVID? Because during COVID, we were at home, we were not going out, and many things were stuck down, and that let environment heal itself. But are we looking for the reverse of it after COVID? Are we moving from the clean environment to again back to what we were having, the polluted environment? So that we have to think. If suppose we are going to use our daily activities like earlier, then definitely we will move towards the air pollution. Then we have to look towards the nanotechnology, how we can use the nanotechnology for remediation of this pollution. And another best example here is Delhi. Everyone might, you might be knowing this, the gate, right? So during this time, last year or before that, you can have a lot of smog, and nowadays you can find it more clear. Why smog is coming? For me, as a nanotechnologist, I find here number of nanoparticles which are coming from the burn crop. Farmers are very good teacher, in fact, because they are burning crop for their own simplicity or for their own convenience. But during this burning, number of particles, in fact, we cannot see those particles because they are very small in size. They are sprayed across the Punjab, Haryana, and Delhi region. And when this winter start accumulating, and then it gives a lot of smog. So we have to think how we are going to use. Can we collect these carbon nanoparticles and convert into a diamond? Because diamond itself is a carbon. China has started working on this. So this nanotechnology is going to give you a better way. Before COVID, we were talking about the plastic, because we are using our own world, our own planet as a dump yard. We are creating plastic. We are using a lot of technology to create this plastic. Even this plastic is very difficult to degrade even in 500 years. Right? Slowly we learn in last 2 years, and we started using these other things like wood or something else. And we were avoiding plastic, right? So literally we learn how to avoid the plastic, but COVID lets us to use in different way. PPE, right? That is again a form of polymer which goes close to the plastic. And what we are observing now, this PPE or this masks are thrown across everywhere. So what plastic was doing, same things this PPE is going to do. These air masks, face masks are going to do. So how we are going to use the nanotechnology for preparing a reusable mask, that's more important. So you can see this nanotechnology is being used for COVID treatment widely. It started with virus detection, then it goes with cloth. What people are trying to understand, what if we put these nanoparticles on the cloth and they can act as a virucidal active virucidals. So you will not need to worry about getting COVID on your clothes. What mask you are using is having a micron pores. But if suppose you are coming in contact with COVID patients for multiple times, then even this mask will not take care of you. So what scientists are thinking, what if we put nanomaterial on the top of it, which can kill the virus easily, and this mask will be reusable. Also, we are talking about auto cleaning. That means what I explained you earlier, use of butterfly. The same way people are trying that what surface is there that we can have auto cleaning property. Surface decontamination is most important thing. Just throwing an acid on the surface will not help you out. You have to put some nanoparticles in that, so the photons, which this light can be absorbed, and these nanoparticles can help you for the decontamination. That the way scientists are thinking. Also, people are thinking of improving immunity system, and scientists are thinking to use nanomaterials to improve the immunity system. Inhibition of the viral, and also in vaccine, they are trying to use these nanomaterials. So nanomaterials are really a candidate for long run. And if you look at the distribution of patent in last 1 year for the nanomaterial, then it goes with more in detection, 19%, than creating a membrane. After that, it moves to antiviral activities. Also, it had been used for biosensors, coating, filters. And now we're talking about vaccine, where people are patenting these nanomaterials for vaccine preparation. Disinfection is not yet more, it is just 1% because we learned to use the nanomaterials for disinfection recently in last 1 year. So sterilization is more there. So definitely this COVID has made us understand that we have to consider nanomaterial for the long run. How these nanomaterials or this nano technology can help you in future. So you can say this artificial intelligence based nano robots. It is very small in size. You can put in your body and you can go for a number of treatments. How does it work? So you can have a capsule where you can fix your nano robots inside. Let this nano robot, this capsule go into your veins. And once it reach a particular place, you can open it using your computer. And then you can guide this nano robot to heal the part which is having a problem. So this is a very good technique going to be in future. So you can think on it. And another is a nanoparticle drug delivery, which has started earlier. And now people are thinking to use this in a COVID treatment as well. The next one is nano gears. The gears are a part of our day-to-day life. When you are starting with your motorcycle or car, you have to consider a gear. But these gears are used to be in a bigger size. If you look at the small size gear, then you have to look towards watch. I'm not talking about electronic watch. I'm talking about old watch where you have the gear system. So what people are trying to convert this gear into atomic size. These are atomic gears. That means you can put these gear systems in your body and can run your any part which is having a problem. And then you can control everything with the artificial intelligence. So you have nanotechnology with you. Everyone might have watched a movie called Avengers, the end game or earlier game, right? So there you can see this Iron Man have one part in body, and once it touch, he can get the super coat. I used to call it a super coat. And then you have a ceiling over here. So just imagine if it happens in a real life. What will be the material to store in such a small size and convert into a bigger or larger platform which can protect you? And that can be only a nanomaterial, right? But only thing is that you have to connect it with number of sensors or artificial intelligence or something like that. That means you have to connect it with the computer. Is it only the limitation? Of course not. There are a number of consumer applications. Around more than 800 consumer applications are being considered with the nanotechnology. And in COVID, you have to consider this. So suppose you have nanoparticles which you spray on any surface, and then your virus is coming towards you. So you can see this is a surface where this person is trying to put a paint, but it's not sticking up. This is honey which is filled inside the bottle. Once you have nanoparticles inside, it can clean up very easily. Even shoes or clothes, you can see here, right? So what if we put the nanoparticle on such a surface, and then do you think that virus can stay over there? Of course not. So this is again true in energy storage. We have used this energy storage. Best example is a mobile phone, which was earlier started in 1983, then laptop, even digital camera, tablets, wearable devices, and many more, where we are using these batteries. And these batteries nowadays are prepared with the nanomaterials. So you can see earlier, this pager phone, which used to be always at a home and always need to be charged, because the material which was used was not having high energy or power density. That means this cannot store the energy for longer time. But people start exploring how we can increase this capacity. So they start reducing the size of the material, and they provided the larger surface where more number of ions can diffuse and store for longer time. And that's why we can have now material in a nano format, which can store energy even for a couple of hours. In fact, cell phone like Apple says that if once you charge it then and use it for longer time, then definitely it can go for 8 hours. So definitely we are using here a nanotechnology. Nano generators is another best example, and it has been used for many applications. It has wide portability as well. What happens here, the scientists are creating one-dimensional structures, nanostructures on one particular brush kind of thing, and then twist it. Once you start twisting, then stress strain used to happen inside the structure, and that used to give you a movement of electrons, and it laid the light the LED. And this particular nano generator is fixed inside the shoes. Once this person starts moving, then this stress strain happen inside and then let it lead the light. So just imagine if you fix these in your tire, then you not need to worry about the light in any time. So security is another thing. The people are using nanomaterials and they are coating a particular area. So these nanomaterials are having a photonic property, so which can excite one particular wavelength. And suppose you design it for your own material, then definitely no one can understand what is there. You have to expose it with one particular wavelength. Then you can easily detect the parts belongs to whom. But this nanotechnology having the advantages and disadvantages as well. Because just imagine you have a very small camera which has been fixed somewhere, then you will under observation. But you have to think about that if such camera can be used to watch the activities of the viruses inside the body, then definitely it will be useful. So even though this nanotechnology has disadvantage, but in future people will start thinking, what if we create such nano cameras and fix inside the body that we can easily look through. Nowadays you might have heard that endoscopy is a very difficult task. Patient will suffer a lot because it has to go through your mouth, right? That used to hurt a lot. But you just imagine if you have a small capsule which you can swallow with water and it goes inside your body and you have connected it with the computer and sensors, then you can easily detect. So you have to think about using this nanotechnology in that way. Nanomachining is another way. So suppose you can build up nano machines, then it will be very easy. So it will be easy to monitor. Also, it will be easy to deliver because of its very small size, and you can obsolete immediately wherever you require. And it can be a programmable with the help of computers. That's why it will become controllable. We are talking about the nano machines, but let's imagine if it happens to be explosive, then it's very difficult task, right? So computer technology can be connected together with the nanotechnology, then definitely you can control nano machines very precisely and you can go way ahead. But at the same time, this will create an unemployment because nowadays everywhere automation is happening. So just imagine if you connect this nanotechnology with that, then unemployment will be there. But you have to think about creating number of applications out of there. So this unemployment problem will not be there. So surveillance will be another issue. As I said, that if suppose you create a nano camera which can be used for endoscopy, the same camera, if suppose someone fixes in your house, then you will be always watched. But you should not look in that way. You should look that you can easily detect the person which is creating problem for you, right? So these are the plus point and minus points always there. But definitely the nano camera can be used in future. So there are different aspects, of course. So if you take this as a problem, then there is no easy answer. For example, if someone asks when we will have a COVID vaccine, right? Everyone is saying after a few days, but no easy answer because it's a very difficult task. So you have to consider the control over the nanotechnology or the factory, because you have seen that many ways you can use the nanotechnology definitely. But suppose it goes in a wrong hands, then it's very difficult. So you have to control the manufacturer option. But for the development of this nanotechnology and comparing this or connecting this with the computer, we should have a global administrative network, which we don't have right now. And if we start comparing these two, then we have to consider the risk of competitive development. So definitely competition will be there, but this competition will let you have a better job opportunities. And to create this, we should have a single international pass program. So this is what we are looking towards the nanotechnology in future. Thank you.
Yes, as it is already said that have such pervasive consequences that the 21st century is already proclaimed to become the nano century. So the explanation and the fact given by Dr. Rupesh Devan sir about the nanotechnology, revolutionary forces and COVID-19 was very trial. Finally, I would like to take this opportunity to thank Mr. Rupesh Devan sir for their perfect, enormous guidance which he has extended to all of us about development in nanotechnology post COVID 19. Thank you. Hope you all have a great day.
Thank you, sir. You have given new insight related to the nanotechnology applications and all. So thank you very much for sparing your valuable time.
Thank you.
Yeah.
So shall I leave the meeting?
Yes, sir. Yes.
Yeah, thank you very much.